Hi, in this video we'll be learning how to use the Polyline struct, and in order to get that we'll go to the RhinoCommon API website and we'll head to the Polyline struct, which is located here, and we'll find that it's a class. Actually, it's not a struct, and it's inherited from the point3d. Okay, so it's under the point3d and under the rhino.collections point3d list. It's inherited from it, and that tells us something here. It tells us that a polyline is treated like a set, like a list of point3d, and we'll figure this out in the constructors and under the properties and under the methods, that it is really used as a point3d list more than a line, and then just the Rhino draws the line that connects those points. So how can we construct a polyline? We can construct an empty polyline, and this, let's say that it's an empty list of a point3d object, or point3d objects I mean. We can construct it using a list of point3d. We can construct it using or initialize an empty one. We can instruct it using some other methods, but our main, and here we find that we can construct it using a point3d list object. But anyway, the easiest way for us as architects, we'll just draw some points, add them to a list, a point3d list, and then create this polyline. In order to do so, let's head to the Rhinoceros and the C# script in the Grasshopper, and to make it somehow faster, in order to make the video shorter, let's create some points in Rhino and add them in the inputs, and let's change the input name to points, and let's change the type to be point3d. And here we're going to explain this for the first time, but if you're dealing with a list, you have to choose the list axis instead of an item axis. This is really important, because if you're adding a list of objects and you use an item axis, the program will not run. So we'll need to use this list axis option, and let's add a point, a point object in Grasshopper and connect it to the points. So here we have a list of points taken from the Rhinoceros interface and added now to our inputs and called PTS. In order to create a polyline connecting these points, all we have to do is write Polyline, which is the name of the class, and here let's give it a name, Polyline A equals new polyline, and here we can choose one of the three constructors, and here we're going to choose our collection of points, which is PTS. And now if we add this to our output and call it Polyline A and run the script, it will draw a line, a polyline connecting these points. And if we change any of these points, the line of course will change here. Okay, let's study the properties, and to do so, let's read from here. We can create a bounding box that contains the polyline. We can get the count of the elements in the list, and this again says that the Polyline class, or any polyline object, is dealt with as a point3d list rather than set of lines. And if we want to get the count of the points then all we have to do, let's test on the site how can we do this. So if we go to the count page, it will be an integer, and we'll say just polyline a dot count. So we can just say b equals polyline a dot count, and if we add a b here and run the script, let's put a slider, a panel here, and check how many points do we have. There are 5, so just as a double check, there are actually 5 points. And if we create another list of points and add it to the points with, let's say, a larger points count, it will actually show here. And let's again go to this and check what else can we do. We can get the first item in the list. So if I want the first point contained in the polyline, I will get polyline.first. If I want to get the length, I will say the polyline's name dot length. If I want the last object, I'll say the polyline a dot last. I can get the x coordinates in the list, the y coordinates and the z coordinates. And as methods, we can add more points to this list, and this will affect, of course, our polyline. So add here is a method under the point3d list in here. So let's try something here. If I say polyline a dot add, in this case we can add a point here, and if I want to add a point after this, so it's like 15 in the x and 5 in the y and 0, so 15, 5 and 0 in the z. If we just run this script now, it will add another point, but it will not add another point to the list, but it will add it to the point list under the polyline. But our PTS list here is not affected. It's still with 5 locally defined points. It will just keeps on connecting the polyline with more points and so on. And we can add range, so we can add a set of elements instead of only one element to the end of the list. So if I want to add a lot of points, let's try it actually. If we add here some more points, let's say those, and let's cancel the polyline.add here. And if we do so and add another list here, let's call a point component and set those points and call this PTS2 and make it list access and make sure that the type hint is point3d. In this case, if I say polyline a dot add range, then I can add the PTS2, and in this case, oh, it's not actually working, but let's see why. Okay, it added only 1 point. Yeah, because we chose this point by mistake, and in this case we have only 1 point, so we need to set multiple points again and select these, and in this case it will work right. So we can add a list of points to our polyline by using the add range method. We can also get the center point of the polyline. We can clear all the elements from the list, so we can make an empty polyline, or make our polyline an empty one with no points. We can get the closest point we can check if an element is contained. So if a point 3D object is contained inside our list, or it goes on our polyline. And we can copy to, in order to change our list to an array. We can also duplicate, so we can create a copy of our polyline instance. We can check if some element exists inside the list. We can find some index, we can find everything, we can find the last element, we can do really a lot of things here. We can get a range, so we type the index that we want to start from, like let's say one from the second point to the fifth point. The second point's index is 1, so I'll type here 1, and I want the second, third, fourth, and fifth, so I need 4 points starting from index 1, and this will give me the second, third, fourth, and fifth point. I can insert an item to the list, and if you see, this is these methods in programming actually are methods to deal with lists, and this again emphasizes on how the polyline object is treated as a list. We can find the last index of an item. We can get the point at exactly the same by the same idea that we did with the line. We can remove some elements, and remove is a list method that exists in the C# actually, and we can reverse the polyline. We can do really a lot of stuff. We can get the tangent at a point. We can make our polyline something called a polyline curve, and let's check this. We can also of course make it a NURBS curve, but let's check what is a polyline curve. A polyline curve is a class inside RhinoCommon. It's separated from the Polyline class. So we have two classes, a class called Polyline and a class called Polyline curve. And the Polyline curve has almost the same constructors as the Polyline. And here we find that the Polyline curve is inherited from the curve class in Rhino geometry namespace. So it's like treating our polyline as a curve instead of a polyline. That's it. And here we can inherit from the curve class its methods and its properties, and this will be really helpful because as we saw in the line, we could not use the dot domain method. We could not change the domain of the line, so we needed to transform the line to a curve first, or any class inherited from the curve class, in order to use the domain method that exists in the curve class. And here under the polyline curve class, inherited again from the curve class, we can find that we can change the domain of the polyline curve. And by the way, there is exactly the same thing happens with the line class, because we can find a class here called line curve. So if we check here, we were studying the line class in the previous video, and here we can find a line curve which is also inherited from the curve class in Rhino geometry. So it gets the domain, it gets a lot of closed properties in the line class. So the line class has 14 properties, but the line curve class contains 24 properties, almost the double of the number of properties, and this is really handy, and you'll need it a lot when you go and work with a lot of complex projects and so on. Okay, to sum it up, we have learned how to use a polyline class in RhinoCommon. We learned how to create a polyline, and that we can, instead of creating a polyline, we can create a polyline curve, and in this case we can get all. If we run it, there is a problem, and it shows us that add range is not included in the polyline curve object. So add range is contained in the polyline, but it's not contained in the polyline curve. So if you want to do it in a smart way, maybe all we need to do is, after adding the range, to say polyline a dot to polyline curve, and that's it. And we can create a polyline object, a polyline curve object, and save this. Call it polyline a curve equals polyline a dot to polyline curve, and in this case we can find the domain. So if we write polyline a curve dot domain, we will find the domain property here, and we say equals new interval, and that will be from 0 to 1. And if we want to get the point on the polyline curve, all we have to do is again write polyline a curve dot point at, and length could work actually, dot point at length, yeah. And here we want it on, let's say 5.5, and here we need to say that this object is a point 3D called point at PLA equals this term, and here we can add C and say it equals to, it is equal to point A at P1A, and add the C output here and run, and this should work, and it will give me the point at 5 units exactly, which is here. But to see it clearly, we can add a point component and find it changing its color here, and that's it. Thank you for watching. I hope this was useful and that you are really entertained with these videos, and see you in another interesting video hopefully. Thanks a lot.